some questions on these applications of artificial intelligence. Xavi, Pachi, this is your field. Okay, that's fine. Thank you very much.
Thank you.
And give the word to Alex to present to TWINECO.
So, hello everybody. My name is Alejandro Fedaque and I am head of studies of this school, and also I'm the responsible for the capstone project that you will be developing in the near future. So for me, that I come from another research area in the origin, it's been a really exciting morning. I think we are merging two different things, coming from the theoretical point of view and merging it with the application that Chu just showed us. For me, it's really fruitful, and I think that we have the future in our hands, and we hope that you, as students, collaborate to reach all the goals that Chu is just pointed at us. One of the main things that I think are really important for this master program is the collaboration between companies and also university. This couldn't be possible without the collaboration of Tyrese, Orobios, Altametris, and also INECO. INECO is it's a Spanish company that is currently developing digital twins and digital applications, and we think that they are one of the top-notch companies here in Spain at these fields. We always, as part of the organizing committee of the master, would like to thank you and the rest of companies for supporting us, for giving us the opportunity to collaborate on real applications on this field. This couldn't have been possible without the help of Sergio del Pino and also Manuel Lozano, that are here today and are going to present us the next topic. Sergio holds an electronic communication degree and also a telecommunication engineer and master here from UPN, and is currently a technical developer of digital twins on telecommunication networks. And Luis is also a telecommunication, sorry if I'm wrong, but I think he's telecommunication engineer and also an air navigation master, also from UPM. With the help of both of them, they have been capable of developing a digital twin of a really sensitive building that we have in the Malaga airport. That is the one that holds the radar. I didn't know that beforehand, but I have just known that radar usage intervals are quite sensitive to environmental conditions, and that's the case for developing a digital twin of this building in order to optimize its development and also its rendimiento. Sorry, I just forgot the word. So please, this is your time. Thank you.
Good morning. Thank you very much for the introduction. We are delighted to have the opportunity to share our insights with you today and to show TWINECO, that is our digital twin for infrastructure. Some years ago, when I first heard about the concept of digital twin, I immediately realized that it brought a lot of possibilities. Through this session, we will try to show you some of these possibilities. For example, the ability to test and predict outcomes, without putting the real system at risk, what is very important in our case. I often wish I could have a digital twin of my own. As I always say to my family or people who want to know what is it, I tell them that it could allows in this case me to have like a real twin, someone who could undergo medical tests or surgeries on my behalf before I do. I think it sounds pretty good. So we want to apply the same concept, the same idea to infrastructure. And we will explain how we can achieve it during this session. We will start by examining the key challenge that the infrastructure operators have to face. Then we will examine how digital twins addresses this challenge. And finally, we showcase a successful implementation as a case study. But first of all, let us introduce our company. TWINECO is a reference engineering and consultancy company in sustainable mobility and digital transformation. For 55 years, TWINECO has been developing comprehensive, innovative, and technological projects that has allowed it to advance toward a new mobility model that is more safe and sustainable. With a multidisciplinary team of more than 5,000 professionals, it has present in all the continents in which it deploys its experience and capacity to undertake projects. It extends to all the transportation sectors, such as urban mobility, railways, or aeronautics, including air navigation and airports, or maritime, road, buildings, and as well as the digital transformation sector. And TWINECO, as a reference in digital transformation, dedicate a significant number of hours to innovation projects, more than 30,000 of hours every year. By means of internal calls, every employee can propose their ideas for execution as an innovation project. Some of them are chosen, and finally some arrives to market. This is the case of TWINECO and other projects, other products. This is one of the aspects of our work that we enjoy the most, because the innovation is in our DNA. And why did we decide to implement a digital twin? What problems do we want to solve? To answer this question, we should give you some context first. And as I mentioned before, one of the fields where TWINECO undertake projects is air navigation. Air navigation is responsible for the planning, control, and management of the air traffic. So the goal is the safety, but keeping in mind minimize the delays and maximize the capacity. For example, in Spain, ENAIRE is the air navigation service provider, and air navigation has been the first field in which we have decided to implement a digital twin, although it can be used, it can be adapted for use in other contexts, such as airport or railways, or indeed whatever infrastructure or building. One of the infrastructure where a digital twin concept proves to be very beneficial is a radar that is a surveillance system using navigation that is used for detecting and tracking aircraft, and they are crucial because they provide real-time information to the air traffic controllers. Don't you think that the next year will be exciting for the engineering? I don't have any doubt about that, and this is the case in air navigation. Objectives such as capacity, safety, cost-effectiveness, sustainability involve demanding challenge that we have to deal with in air navigation. Moreover, there are hundreds of air navigation infrastructure distributed through the territory, some of them in the middle of nowhere, which implies high operating and maintenance cost. For this, it will be essential to rely on tools that help us in decision making in a more and more complex and volatile context, with an increasing number of systems and information sources. Moreover, these tools should let infrastructure operators optimize their operation, keeping in mind sustainability. So, current trends of centralized information, interconnection of systems, or new technologies such as IoT, artificial intelligence, or BIM can be the best enablers for infrastructure operators. And indeed, they are implementing and deploying these technologies, although these technologies operate in separated silos. For instance, in air navigation radars of ENAIRE, they were integrated in an IoT system in order to monitor the energy and climate systems. And on the other hand, there were BIM models, but there wasn't any relationship between them. In order to exploit the synergies of using these new technologies all together, it is necessary a solution in order to integrate them into a single system as a whole, and this is the reason why we decided to implement and deploy a digital twin. Infrastructure operators can take advantage of this concept, and we will show through an example the success case of TWINECO. As a result, TWINECO works as an integrator of information and tools based on new technologies that enable quick decision making, optimize operation, reduce environmental impact. This system let us perform immersive browsing through the three-dimensional model. Besides the information that comes from the BIM model. In addition, and I think it's one of the parts more important, is that it gives access to real-time data related to the operation of the shelter and equipment of the radar. This information is provided by sensors and a deployed IoT system, besides other information sources such as meteorological information. Consequently, TWINECO empowers infrastructure operator with a decision-making tool that enhances situational awareness during the operation by centralizing the information at a single point. For instance, it lets you know right from your desk the exact location in the shelter of a malfunctioning device, and it helps you to determine what tools you need for repairs. TWINECO also has a better performance than traditional monitoring and management system because it enables simulation and predictions, optimizing infrastructure operations, and as a consequence, it enhances maintenance efficiency, sustainability, and resilience using artificial intelligence and machine learning models for predictive maintenance, energy optimization, or the ability to simulate different contingency scenarios. For example, engineers can ask questions like, what if we increase the shelter temperature by 2 grades? I mean, how would it impact to the energy consumption or the equipment performance? Or what if the air conditioning fails? One of TWINECO's strengths lies in its flexibility and scalability, allowing the integration of additional information sources and simulation models, and adapting to evolving needs.
Okay, and now, hello everyone. Now I'm going to do a brief explanation. Okay, sorry. This is the next. Okay. First of all, we can differentiate 3 main parts of the application. One of these dedicated in the generate the user interface, commonly called the front end. Other to manage the information through the application, that's the backend. And around it, the rest of the information access services. This information comes, for example, from the IoT systems, the SCADA systems, or the sensor deployed in the building. Or, for example, other external sources of information like IMET to obtain the meteorological information of the place. Also, it's important the access to the artificial intelligence model developed and the acquisition of the 3-dimensional model coming from a BIM project and the necessary tools for interact with them. This architecture improving the performance of the application and allows a great scalability when to try to connect for new sources or new buildings. Okay, now we'll try to introduce the application by exploring its key functionalities. Given a guided tour of its navigation interface through the building and the visualization of the data. In addition, we will show you the access point of the simulation tools, as well as the representations of the result generated from the artificial intelligence models. To do this, we will show you some videos using the application where you can see each of the three main functionalities, which are the navigation from the three-dimensional model of the building, the real-time information windows, and the simulation tools available. In addition, we will try to describe the main characteristics of each one. And therefore, let's watch the first video. Okay, as we can observe, TWINECO shows a clean and intuitive interface that highlights the three-dimensional model of the building and all the navigation options to the application, all using, for example, drop-down menus and other pop-ups for the different options and the elements of the application. In this way, users can easily navigate through the floors and on all the rooms where we can find all the devices and their respective properties. In addition, the interface provides an instant display of the essential information for the maintenance of the operation of the building. For example, users can easily check the alarm status of the equipment, painting in red in case of alarm, or as well as the climate details of each room, all clearly displayed on the 3D models, using, for example, a heat map over the room. The application provides a comprehensive view of the site's attributes from a single point. It provides information about the environment and the current status of all the equipment. And for the next, in the following video, we can see how the data of each device is displayed. Let's go. Okay, TWINECO has the capacity to not only show limited data, it can also handle large volumes of real-time information for all equipment. The application provides some operational information windows which can display all the discrete or the analog data collected by the sensor or the IoT system deployed in the building. This capability allows us monitoring the operation of the all equipment. In the event of an error or alarm, it's easy to locate the reason of the incident. In addition, we can cross-check all the regular operation data with the maintenance actions. In essence, TWINECO can host all the pertinent information about the physical asset, making it accessible from anywhere and through a unified platform. And now, to finish, we will see the following video, in which we will see some of the simulation tools that have been developed using the artificial intelligence models. Most of them are related to achieving the sustainability objectives and the optimization on the building energy consumption. Okay. Similarly, we gain access to simulation and prediction tools that empower us to achieve objectives such as the resilience and the sustainability of the building. These tools enable us to configure and generate results from artificial intelligence models, all with a visual representation in the application. This will allow us to see the result obtained over the time represented on the three-dimensional model. Some of these tools are designed to achieve sustainability goals. For example, by optimizing the energy needs of the air conditioning equipment, basically analyzing the historical consumption data and the climatic condition of the place, and modifying some of the air conditioning parameters, such as the temperature of the climate machines. On the other hand, others have been designed to detect the impact of possible equipment failures. For example, simulating an scenario in which air conditioning equipment fails. These tools allow us to know the time it will take from the failure of the air conditioning equipment until the room reaches a temperature that we can consider dangerous for the correct performance of the radar equipment. In addition, the evolution of the room temperature over the time represented on the three-dimensional model. In essence, these tools elevate the level of control and monitoring of infrastructures. They use real-time and historical data from the installation to make predictions and simulate scenarios that optimize its operation. And to finish, in conclusion, TWINECO is a game changer. It improves maintenance operation by centralizing the information from different sources, improving the situational awareness, and making easy the data-driven decisions. Moreover, TWINECO incorporates simulations, prediction, and optimization tools that enhance efficiency and sustainability, for example, by optimizing the air conditioning needs. Apart from that, TWINECO has the ability to perform contingency impact simulations that significantly improve the infrastructure resilience. And that's all. Thank you for joining us in this exploration of TWINECO and the world of digital twins. These technologies will revolutionize the way that we manage and optimize our infrastructures. Feel free to ask any question, of course, and we hope you found them interesting. Thank you very much.
One question. I will start with that. What is the reception of the feedback that you are receiving from public administrations when you are proposing similar projects to be developed?
We have had a strong, I must to say that NIRE in this case have loved the project since the beginning. We have had a lot of help from them, and the reception has been very good. Sergio, for example, has trained a lot of engineers of NIRE, and the feedback has been very positive.
Hi, I am Pachi Cartell, a student for the Masters. I have two questions. First one, well, congratulations for the presentation. I like a lot. And first question is about the interface. I like a lot the interface that you made. Which technology do you use for the interface? This is the first one. And the second one is, are you going to apply this model to other domains, for example, data centers, that I think that the problem is more or less the same that you are using here? Thank you.
Okay, thank you for the question. The interface, the user interface, is a commonly web application, and we use some frameworks for the front end and some framework for the back end. A lot, for example, in this case, some of the part of the backend is in Node.js, and other parts is in Python, and the front end, or only the interface, is using the React framework. And for the second question, I think the most important part now for us to include new buildings or include new models is the model. Is to add the model is really necessary to develop a space where we can to add in our team, no team, in our space, develop space.
And data centers is in our roadmap, and we want to use this kind of digital twin for the data centers of, for example, air navigation service provider, NIRE. But it's in our roadmap, and we hope to could afford this kind of projects. But it depends on the innovation department too. So, but it's obviously in our roadmap, because is the next step, to go to a bigger infrastructure. Thank you for your questions.
Next question for Rubén. Rubén is part of the BIM team of the Escuela de Caminos, and they have developed a BIM model of the escuela, of the school, which is now coming to life with a digital twin, and I'm sure that you have a lot of questions.
Well, hi, hello, thank you for your presentation. I have two questions too. The first one is related also for the front end. Have you considered, you mentioned the front end of React. have you considered the other front-end framework like Angular, or why you choose React over Angular? And the second one is, which is the standard that the platform, or the standard related to the digital twin that the platform is able to render into the front end? Is IFC, or are Revit models, or any specific format? Thank you.
Okay, we consider React because at first we tried to do an interface around the model, the 3D model, the environment of the 3D model. And React is good for do a one-page application, and this is the reason. And okay, yes. In this case, TWINECO have a department to develop the BIM models, and we adapted to the format that we use. In this case, is Revit.
Hi, my name is Beatriz. I'm a student too. I understand that you cannot operate with the digital twin, or you can you, if you can, depending of the results or the consulting data, you can turn off or on the lights, for example. You cannot operate, or this is a goal in the next in the future.
It's absolutely possible to do it, but not in this moment, but not for technological reason, but only for I mean, sometimes in the technical people have some kind of fears about this kind of remote systems, so we prefer in the first step only to give this kind of functionalities, not the remote control, but not for technical reasons. It's perfectly possible in this moment. It's only because we prefer not to kill the system at the beginning because of that. For the fears it could that technician could have for it.
But maybe you can use the simulation or prediction to know how to have to
Yes.
turn the lights or not.
Yes, this is what we use at this moment, the digital twin.
The human does this.
Yeah,
This question.
it could be technically possible to do it automatically and remotely, but we prefer not in this moment for this.
Okay, thank you.
Thank you very much. Sergio, please. Okay. So this is it for the morning. I guess that our European friends are starving quite much. I would like to thank a lot to all the lecturers today for your effort coming to the escuela, particularly to Eduard and Chus who had to travel today, and especially for sharing your knowledge, which nowadays is very, very appreciated. I hope that you have enjoyed the morning, that it has been fruitful for all of you, and we hope to also be at the same level in the sessions that we will be organizing in the following days, which I know that they are quite interesting. So before we leave for lunch, the agenda this afternoon for the learners will continue. We will have a visit to to the Museo Torres Quevedo, which is the origins, and you realize that it is one of the origins of artificial intelligence. I know that you will enjoy it, and then we will have a couple of lectures, one from actual UPM on entrepreneurship and innovation, and around the possibilities of innovation with UPM, and another about lean construction and the application of digital twins, a lecture by Onur, who just came from Istanbul a few minutes ago. So thank you for being here and for your attendance and for your lectures. Yes.
Do you take the opportunity that we will gather to have a group picture?
Yes, I think Lucia is on that. Yeah.
Before everyone
Yes, we need to take pictures today after the visit to the museum in Torres Quevedo.
Okay,
And tomorrow with the capstone project.
Yes,
So
great. Yes. And the companies, that's yeah.